Let's take a moment to recap what we should know about algebraic expressions. So over here we've got 5x cubed plus 4x squared minus 3x minus 2. And I've written down 3 very important terms here. We've got a variable, a constant, and a coefficient. Alright, so a variable is something that can change by definition. So in this case, we've got an x in this expression, and that x could represent any number. And when we get onto other sections of maths, we actually start to substitute values in for x. So that's known as our variable. Then something that cannot change is the constant term, and so that would be something that doesn't have any variables, and that would be the -2. Very important that we bring in the sign. And then finally, a coefficient, that's not the same as a constant. A coefficient belongs to another term. So if I were to say to you, what is the coefficient of x squared, you would then have a look and say, okay, what number is written in front of x squared? And that would be a positive 4. So the coefficient of x squared is 4. Alright, another thing that's important to remember is the word term. We need to know how many terms we are dealing with. And terms are separated by plus and minus signs. So if we look at those, we can see we are dealing with 1, 2, 3, 4 terms here. Okay, so that's the basic terminology behind an algebraic expression. Another thing that's important for us to know is the difference between an equation and an expression. So if the question that they give us says solve for x, then generally what we'll have is something like 2x plus 17 equals 21. And then you can solve, and what is important to note here is that there is an equal sign present. Okay, that makes it an equation. On the other hand, if we are asked to simplify, then we will be given something like 2x plus 17 minus 21, and we would essentially be putting the equal sign in, and we would gather our like terms, and we could then say this is 2x minus 4. So 2 different types of algebra, equations and expressions. What we are focusing on for this lesson is algebraic expressions, and the question here is simplify. And what they mean when they say that is answer or solve or do the question. Okay, so don't ever be thrown off by that. Simplify simply means do this maths. Okay, so in our first one we are asked 3x squared, and then it is being multiplied by this bracket. Okay, so this is a recap of last year. We would literally multiply that 3x by every term inside of the bracket there. So we'll end up with the 3x squared multiplied by 2x to the 4. So I generally go and I check the signs. A positive times a positive is a positive. Then I'll do the numbers. 3 times 2 is 6. And then finally, the variables x squared times x to the 4 means there are 6 x's in total. And then we'll do the same with the second term there. So positive times positive gives us a positive. 3 times 1 is 3, and that is all being multiplied by x squared. Next up, if we look at question 2, we are given 2 brackets being multiplied by each other. There are 2 terms in each bracket, so this is called a binomial times a binomial. And what we will have learned to do last year is something known as FOIL. So we will multiply the first terms, then the outer terms, then the inner terms, and finally the last terms. So let's start and multiply the first terms. X multiplied by y is xy. The second thing we're asked to multiply is the outer terms. So that's x multiplied by minus 7. So positive x multiplied by negative 7, plus times minus is minus. 7 times x is 7x. Then according to FOIL, the inner terms, so we're going to have a positive 2 times by y, and finally our last terms there, a positive 2 times a negative 7 Plus times minus is minus. 2 times 7 is 14. And once we have FOILed, we then check, do we have any like terms? And in this case, we don't. So those are our final answers. Let's have a look at some more examples of simplifying. Over here, these two questions, question 1 and question 2, they may look quite similar, because if we were to just expand question 2 here, we would end up with x plus 4 multiplied by a bracket that looks exactly like that, x plus 4. Okay, so let's have a look. This one is just slightly different. One of the brackets is a negative. Let's have a look at what's going to happen if we FOIL these brackets. So we're going to multiply our first terms. X times x is x squared. Then, according to FOIL, our outer terms. X times positive 4 gives us positive 4x. Next up, the inner terms. Minus 4 times x is minus 4x. And finally, the last terms there. Minus 4 times positive 4 gives us an overall minus 16. So what do you notice here in the middle, grade 10s? A plus 4x minus a 4x. So that leaves us with x squared minus 16. And if you remember correctly from grade 9, this was known as the difference of two squares. So when I have a square, x squared, and a square, 4 times 4, I could factorize that into x minus 4, x plus 4. Alright, let's see if the same is true here when I am squaring the brackets. So I'm going to FOIL again. I'm going to start with the first terms there. So we've got x times x, which is going to give us x squared. Then the outer, x times positive 4 is positive 4x. The inner terms, 4 times x. And finally, the last terms there, 4 times 4 is 16. Okay, so again, if we look at these middle terms, we'll notice they are like terms. 4x plus 4x. This time, because their signs are the same, it becomes 8x. So x squared plus 8x plus 16. So to pay attention, when we are doing difference of squares, our middle terms will cancel each other out. But when we are squaring a bracket, be very careful not to just go x squared plus 16. No, we need to expand it and FOIL. And what will happen is we will have our first term squared, our last term squared. And then what will happen is we'll multiply these two inside terms, 4x, and double them. Okay, and that is a little shortcut that you can use whenever you are given a square of a binomial. Now let's have a look at a different type of multiplication. We've got 1, 2 terms here, and 1, 2, 3 terms here. So it's a binomial multiplied by a trinomial. Now we don't have a cool acronym for this like FOIL, but the same principle is going to apply. So we are going to use this first term p, and we're going to multiply it by every single term in the next bracket. So let's do that first. Alright, and we're going to check our signs. In this case, all the coefficients are 1, so our multiplying of numbers is going to be quite straightforward. And we can just go for it then and do our variables. Okay, so starting off with p multiplied by p squared. Those are all positive. So we'll have p to the power of 3. Then our second term, a positive times a negative, is going to give us a negative. P times pq is going to be p squared q. Then we look at the third term there. Positive p times positive q squared. That's going to give us positive pq squared. So there we've done the first bit of multiplying. Now we're going to do the same thing here with q, and we're going to multiply it by every term there in the second bracket. So it's plus a q, and so that is going to end up being plus p squared q. Alright, so it's not wrong if you write qp squared, but in general we write our letters in alphabetical order. Next up, we're going to take that q, multiply it there by the middle term, Positive times negative is negative. PQ times PQ is going to be PQ squared. And then finally, we've got our last multiplication happening there. And that is going to give us plus Q to the power of 3. Okay, let's gather some like terms. P cubed, there's only 1. P squared Q, there are 2 of those. And PQ squared, there are 2 of those. And then again, only 1 Q to the power of 3. So now if we collect our like terms, we'll end up with P to the power of 3. Then we've got minus 1 of these plus 1 of these. So they're going to cancel each other out. And we've got a plus PQ squared and a minus PQ squared. So that again is going to cancel. And then we'll just be left with this plus Q to the power of 3. Now what's going to happen is they're going to start bringing all of these different types of multiplication together, and it's very important for us to understand the order of operations. So we've always followed this: brackets of division, multiplication, addition, and subtraction. But at grade 10 level, it is actually very helpful to adapt this slightly, and I'll show you how. Most of BODMAS will stay the same. B, do your brackets first. Then we're going to change the of, because it's very uncommon to find of in our questions. We're going to change that, and we're going to start doing our exponents second. Things like raising a power to a power or multiplying the same bases. Next up, we'll do the division, then multiplication, then addition, then subtraction. And it's worth noting that we are allowed to do division and multiplication in one step, and we are allowed to do addition and subtraction in one step, from left to right, because they are essentially inverse operations of each other. So that's something that's going to save us a bit of time now that we're in grade 10. Let's have a look at one of these mixed examples, and you will see that you are very capable of solving these kinds of questions. We're going to start by doing our brackets. Okay, so having a look here, are there any like terms? No. Are there any like terms here? No. Next up, we're going to deal with the fact that there's an exponent here, and I'm going to do that by writing that bracket twice. Okay, if you are confident in your ability to square brackets and that you're not going to forget the middle term, then you don't have to write that bracket twice. Okay, now we're going to multiply. So we're going to put this A into the bracket there, and later on we're going to FOIL this bracket here. Okay, be very careful. Here's a minus and a 1. Okay, remember, when there's no coefficient written, we can assume that it is a 1. So later on, that's going to have to go into that whole multiplication, and we're going to have some sign changes. So there's quite a bit going on here, but we definitely have what it takes to tackle this question. So we're going to have a squared plus 3a plus, have a look at this 6. This 6 is independent of everything else, and so we're simply going to write it as a plus 6. It's not multiplying with anything. Now we are ready to FOIL. A times a times minus 1 times a, and minus 1 times minus 1. Now that we've done that, let's collect these like terms inside of this bracket. So we'll have a squared plus 3a plus 6 minus a squared minus 2a plus 1. And then we are ready to multiply that invisible 1 into the bracket. Okay, and what we need to note is that that negative is going to result in a sign change. So we'll have a squared plus 3a plus 6 minus a squared plus 2a minus 1. Alright, now we can collect our like terms. So a squareds go together, a's go together, and constant terms will go together there. Okay, if you want to, if you're scared you're going to make a sign mistake, you can rewrite them in order of like terms, but I think we can tackle it from here. Positive a squared minus a squared means we've got no more a squareds left in this question. Positive 3 plus another 2 gives us 5a, and then plus 6 minus 1 gives us plus 5 as a final answer there. Let's tackle one last example. Here we've got two brackets. They are the difference of squares. So if you remember from earlier, we saw that that meant we would square the first and square the last, and the sign would be negative. When we're dealing with difference of squares, two identical brackets with different signs, what's going to happen is the middle terms will cancel each other out. And if you're not sure, you can FOIL that and you'll see you'll end up at the same place here. Now let's have a look at what's happening in the second part of this question. We've got a minus. Remember, it's kind of like an invisible 1 there. So minus 1 needs to be multiplied into this bracket here. So we'll end up with minus x squared plus y squared. That's the second part of the question there. And then let's get some like terms together. So x squared goes with minus x squared, and minus y squared goes with plus y squared. And what do you notice? Everything is going to cancel with everything, and we will simply be left with 0 as our answer.